Thank you for those who've let me know already. Looking to get started just in a minute. So I think we'll get started there. So hi everybody, I'm Alex. I'm from the Leaders Award team. Welcome to our online engineer interview today, featuring Stuart Calvert from Network Rail. Just as everyone logs on, I'm just going to do a little bit of an intro. So just before we get to Stuart, I'll run through what's going to happen during the session today. As there are lots of people watching the event, we've muted everybody except for myself and Stuart for the whole event, just so there are no interruptions or real loud feedback. The first part of the event will be Stuart's presentation, and then we'll go to the second part, which is the Q&A section. Please feel free to type in your questions any point during the session in the Q&A facility, or you can use the chat section for that as well. Just as we get into the Q&A section, then we can get straight into answering as many of your questions as possible. This will be similar for those on Facebook. If you're watching on there, please post your questions into the comment section as well. I'm just going to explain a little bit about what the Leaders Award, if you're an engineer, what would you do competition is all about for those who are coming at this fresh and have not experienced it before. Its main aim is to inspire young people ages 3 to 19 to look at the world around them and start designing some solutions to problems and start designing some of your own inventions. So this could be a problem really small as, say, brushing your teeth in the morning, to a worldwide problem such as renewable energy. We provide opportunities for you to meet and interview engineering professionals online, just like we're doing today with Stuart, to inspire you to think of ideas and start designing some of your own inventions. And to help you with this, we've got lots of available resources on our website at leadersaward.com. So now, without further ado, I'm going to pass over to Stuart. Hi, Stuart.
Checking, can you hear me okay?
I can hear you perfect. That's it, Stuart. Hi, how are you doing?
Very good, how are you?
Brilliant, thank you, Stuart. I'm just going to make sure we can see you as well. So I think I've just asked to share your video. Perfect, can see you there. And I'll make sure now that you can share your screen with your presentation.
Okay, let's share that now.
So if anyone's got any questions for me at all or for Stuart, if you want to post them in the chat section, or you can use the Q&A section for that as well. I can see your presentation there, Stuart, which is brilliant.
Excellent,
so
thank you.
Whenever you're ready, off you go.
Well, thanks very much, Alex. Thanks to everybody for letting me spend a bit of time with you this afternoon. I'm just going to talk about what I do, try and explain what inspired me to become an engineer and to get where I am. Explain a little bit about my background, what I've done, what my current role is, how things have changed over time, and what I think the future holds for future engineers and any advice there. So I'm going to start off with saying a little bit about what I do as Capital Delivery Director for Network Rail in Wales and Western. So hopefully you can see a slide with a diagram showing the part of the country that we look after. It's a large section, the whole of Wales and the whole of the railway lines from Paddington in London down to Penzance in the southwest, down to southwest Wales, and in fact all the way up to North Wales. So it's a large part of the country. And in terms of my responsibility, I'm responsible for leading the team that manage all the investment projects we do across the whole of the region. So It's a mixture. Hopefully you can see a slide now with some photographs of some of the work we've been doing recently, or we're just about to do. We've just electrified the railway from London to Cardiff, and that's gone live in the last few months. We do extensive track renewal work every weekend, renewing the tracks to allow trains to run safely. Bottom right of the picture, you should be able to see some seawall work we're doing in Devon, near where I live at the moment, which is to provide resilience for the railway. And in the top left, a major timber structure we're about to embark on. Interestingly, when I started as an engineer, one of the first jobs I got involved with was replacing timber on that bridge nearly 40 years ago, and we're just about to do another round of it. We also build bridges. We do electrification work. We do track maintenance work, heavy maintenance work. The photograph you've got now should show a large bridge we're building in the Bristol area. Track renewal work again, embankment resilience work. A lot of our infrastructure is obviously quite old, and we have to keep it in good condition, so strengthening embankments and so on. So it's the whole range of engineering, civil engineering, electrical engineering, signal engineering, and so on. So what I want to move on to now is how I got into engineering and what inspired me. And hopefully you will have a slide that has come up with some a range of photographs, and I'll try and explain what exactly these mean to me. So the top left, you can see a bridge. It's a bridge that links Devon and Cornwall, and it's something I distinctly remember going on holiday when I was quite young, going across that bridge by train and looking out and just thinking, what, you know, this thing, what is it? It's just this huge steel structure. How does it work? You know, and it really did make me think. Similarly, when I was growing up, I used to enjoy building things as a picture meccano. Some of the older people, I'm sure, will understand what that is. And for younger people, it was basically a way that you could build stuff, you know, miniature construction in your house. And I used to love doing that. The other thing when I was growing up that was going on was it was our first serious space exploration in the world. Bottom left is Neil Armstrong on the moon, and the top right is mission control that controlled all the Apollo space missions and the lunar landings. And in there, the man leaning against the wall is a guy called Gene Kranz, who was the flight commander. And I was just couldn't, you know, at that stage, doing what was achieved in those years was just incredible, and just something I was completely fascinated by, and have been ever since. And particularly people like Gene Kranz. What were they doing to make this happen? And then the bottom right, there's some older people. There's Stevenson, Brunel, and Telford, great engineers from Victorian times, and I enjoyed finding out what did they do, how did they go about doing things, because they weren't just engineers, and I read a lot about them. So that was my inspiration. That made me think. It made me very intrigued about engineering and how you build things and how you do amazing things. And that was my first inspiration. What I'm showing you now is a couple of books, actually, and as I got a bit older, in fact, just before I was going to university, the book on the left, Structures or Why Things Don't Fall Down, was a book that I was recommended to read before I went to university. And very simple penguin book. And again, it's just one of those things that explain how things work, how structures work. So a very inspirational book. I've since found out, I was obviously a trendsetter, that it's one of the books that inspired Elon Musk as well. So it can't be a bad book. And on the right, there's a book called Red for Danger. It doesn't sound very inspiring, but it was a book about railway safety and about railway accidents and why. And I just found it fascinating about how systems came together to make a railway system work, and how you brought together railway signalling with people, and how people behave to make railway safe and make the railway work as a system. And that's probably what inspired me to look for a career in the rail industry. So what have I done? I was lucky enough to be sponsored by British Rail to go through university as a civil engineer, and I joined British Rail as a civil engineering graduate trainee, went through university with British Rail before moving on through a variety of companies, Railtrack, Jacobs Engineering, Bombardier, and the roles I've taken were as a civil engineering trainee, but I very rapidly moved into project management, and I'll talk a lot more about that shortly. The next slide is just a series of photographs showing places that I've either been educated, my school, my university, Sheffield. Big shout out for Sheffield University, great university focusing on structures. But then some of the places I've been lucky enough to work through my career as a project manager. Now, what project management? Taking the engineering, managing the whole aspect from developing costs to delivering the work to working with people. And I'll come on to my role today leading project managers, but I've been lucky enough to work across from Greece, from Valencia to Rome, and even to Delhi in India. And I think engineering is one of those professions where you have the opportunity to work in all sorts of places around the world and to get things, but you also can obviously work locally. So it's been a fascinating career in terms of getting experience across the world. So what's my current role? So as Capital Delivery Director for Network Rail is obviously responsible for a critical national asset. We look after all the infrastructure on the railway in the UK, in England, Scotland and Wales. And it is a critical national asset, and that's probably come home to a lot of people recently, where we've been moving freight and key workers during the COVID pandemic. We're obviously accountable for extremely large sums of public money. In Wales and Western, the investment that we spend each year is around about £1 billion a year. So it's a critical national asset and accountable for large sums of public money. Well, am I also responsible for improvement? All the time we're looking for improvement. How can we spend that money wisely and look after public money wisely? And I'm also responsible for leading the team and getting the best of people's knowledge and skill to invest efficiently and effectively. And probably most importantly, it's developing solutions, a problem solver. And that's what a project manager and an engineer is, a problem solver, developing solutions that give benefit to passengers and freight users. And in that role, I'm a leader, I'm a teacher, I'm a problem solver, I'm an engineer, I have to be a politician, an accountant, and a friend. Because engineering is not just numbers and concrete and steel, it's people. And it's developing the people who are going to work in it and the people who are going to use it. So you have to have great communication skills. And I talked about the importance of change, and I just want to show you some of the things that have changed, and in particular focus on the safety aspect of how things have changed as engineering has evolved. So there's some photos that were me working in the 1990s, I think, and you can see there some things that are, I just find incredible that we allow people to work in that way, hanging off ladders, working with no protection, and so on. And there's a great picture of me there with the amazing high visibility equipment that we used to use. But another thing that's changed is fashion. So bottom right is a project meeting in a porter cabin with some absolutely incredible jumpers on display. Track renewals, we do a lot of track renewals. We're probably on about 10 to 15, 20 sites just in our region alone where we're renewing the track. This is how we used to do track renewal. Again, people with very limited protective equipment and just working in what appears a fairly ad hoc manner. And the improvement we're looking at is not just about safety, it's about efficiency and so on. And so the photo I'm now sharing with you is how we've moved in terms of taking care of people, using far more effective equipment and driving efficiency to enable us to do work. And in the bottom right, of course, we've recently done some incredible changes in construction and engineering to take allowance of the COVID pandemic and so on. So again, another problem that we've solved as engineers. So what's the future? To my mind, the future of engineering is actually the same as the past. Engineers always have been problem solvers, and I talked about all those various other issues, politicians and so on. So it is the same as the past, but the difference is we've got far better understanding of materials, of engineering, of systems and so on. We have far better tools to hand, computers, robotics and so on. And we actually have different values, because one of the things that has been really striking in everything I've shown you, I think until I showed you a picture of what has changed, virtually everybody involved was a white male. And when I was growing up in engineering, that was pretty much the norm. So we have a different way of working, and just understand how you cannot have white male dominated industries. So things that will change in the future, we're still solving problems, but being much more open and inclusive, and understanding how that is a far more effective way of working. And it's also really important in terms of ethics and morality as well. We have to be responsive and agile, and even more so, people demand change much more quickly. And in fact, fully inclusive teams are far better at doing this because they're far more open. And that's my experience of working over the last few years. So our skills, our knowledge, and our experience in the future are all about doing things safer, providing better performance and better facilities for people, doing things quicker, and creating much better value for people. I'll just show you this slide. Just before I did the role I do now, I worked in what we call the digital railway in Network Rail, where we looked at all sorts of technology that do some pretty amazing things for the railway, whether it's monitoring equipment. The picture of the trains there about providing monitoring of the track and the overhead line and structures to provide information for maintenance engineers at full line speed, 125 miles an hour, gathering huge amounts of data and information to allow us to manage the infrastructure better, whereas in the past we'd have walked the track and looked at the track and structures and so on to see what condition they're in. But also the digital technologies help us to improve how we build things and how we design things and so on. So the takeaways for me and my advice to anyone want to be an engineer, and that was a real whistle stop through what I do and what I've done, but these are some things that I've always done throughout my whole career. First of all, be inquisitive. I put the 7 whys. It's one of the things I was taught and I learned very early on. If you want to find out how something works or why people do things, ask why, and then ask why again, and then ask why again. And by the time you get to the 7th question, you'll probably get to the bottom of what it's all about and you'll learn something. The second point is get your hands dirty. And I don't necessarily mean literally, because engineering is not all about construction. It's about software. It's about clean factories as well. What I mean by getting your hands dirty is really get in and understand how things work. You cannot be the boss of a factory on day 2 of your career. You've got to understand what works and how things work and how people work. So really get in there and understand it. And that's really the third bullet point, which is not to be superficial. Understand the detail. You don't have to understand and do all the detail, but understand the detail behind the big picture of something. Don't just sit at a superficial level. And as I said before, engineering is not just about construction or about maths and numbers. It's about working with people, and you have to earn respect. There is no quick fix. Hard graft pays off. Skills you should have: be a problem solver. Engineers are problem solvers. How do you build something? How do you create benefits for people? How do you create economic growth for a city? But it's not just about science. It's about your artistic skill as well. Being a great communicator, inspiring people, thinking about how you impact on people are artistic skills that support your scientific skills. I've talked about communication, and you do, if depending on where you want to work, you might be one day talking to a politician, the next day you're talking to somebody who's worked in a factory all their life, and every other day you're working anywhere in between. So being able to communicate what you want and understand people, and that's probably the most important part of communication, is listening, is really important. And my final point is find something you enjoy, because there is absolutely no point in getting involved in something that you're not going to enjoy and inspire yourself. So find something you enjoy and make sure you really enjoy it. So on that, I think that's all I wanted to say, and I'll hand over to questions. So thank you very much.
Thank you very much, Stuart, for your brilliant presentation there and sharing that with us today, and lots of really good advice there at the end. Just as Stuart said, we're going to pass over to some questions now. So if you would like to, the participants, if you'd like to post them either in the chat section or the Q&A facility, or if you're on Facebook, you can put them in the comment section there. I'd just like to start off with a question, if that's okay, Stuart. The first one I'd like to ask you is, you were talking about structures earlier on in your presentation. What's kind of your favorite structure, maybe that you visited before or that you'd like to visit?
So I showed a picture of it, the bridge across the Tamar. So it was one of the first bridge, it's weird, isn't it? First bridge I remember. But I was inspired by it as a sort of very young boy going across on a train, because of the sound, it was noisy, looking out. And then I learned actually what Brunel did on that structure was he combined the three main elements of bridge design in one bridge, which are an arch, a chain, and a simply supported beam. And he did that because he had a huge problem with the Tamar, which he had to have a very high headroom to allow naval ships through. But there wasn't anything either side that he could do the normal structures of an arch. And an arch pushes outwards and a chain pulls it inwards. So he had to have slender columns and a high span. So he worked out, well, actually, if I do both, if I have an arch and a chain working together, it won't put forces outwards or inwards, so I can have slender columns. And it was brilliant, and it still is.
So the next question we've got is asking about the roles that you listed in your presentation. You said about kind of being a teacher, being an engineer, being a politician. Which one of those do you feel like you enjoy the most, or have you kind of learned to enjoy the most?
Working with people. No question. The engineering's great fun. The engineering is absolutely brilliant fun, but it's working with people and seeing how people develop. I've done a lot of work in that area. I've been a governor of a UTC. I've been on an advisory board for an FE college. I've taught project management at postgraduate level, and I think that bit of working with people and helping people grow is probably the most enjoyable part of the job, full stop. And you do it all the time. I mean, one thing I say is I'm learning every day. Every day I learn something, whether it's engineering or management. Every day I do, and actually, you know, an important role as a leader is how you can get the best out of your team. I mean, I'm not doing the engineering anymore. I'm not designing anything, but hopefully I'm supporting people who are doing the engineering, and that's a role as a teacher. It's the most enjoyable part of the whole thing.
And that's like a really important thing that you said then, wasn't it? Like you're working in a team, and teamwork's really important with what you do.
Teamwork's essential, and something I touched on during the presentation is the most effective teams are diverse in every sense. Different skills, different ability, different knowledge, and the normal diversity of gender and ethnic background. And actually, you know, working out how you get a team to work together, because engineering depends, you know, everyone's not the same. Everyone's not a civil engineer. You've got accountants, you've got commercial people who deal with contracts, you've got people who deal with the customer, you know, and so having a team and understanding how you make teams work is vitally important, because virtually nothing we do in this game is about individuals, and if it is, it generally doesn't work very well.
Like you would say, then it's very diverse, the different roles that you can do with engineering. So kind of anyone can be an engineer, and anyone can
be involved in engineering. And I talked about arts before, and you know, whatever background you're from, you don't have to be brilliant at maths, because Some people are, and the people who are brilliant at maths will do the things that require things to be brilliant at maths. Yes, you generally, if you're going to be involved in design and stuff like that, you're going to have a good mathematical background. But being involved in engineering is not all about the design and construction. You can be involved in commercial management. You can be involved in business management. You can be involved in resource management and training, and and so that brings that variety of abilities to come together to make something really work. And you can like engineering and be involved in engineering without being an engineer.
And that's brilliant for those listening today who may think, oh, I'm not that interested in maths, or I'm not the greatest at maths or anything like that. Like you said, then they can still get involved in engineering as well. I just want to touch on, obviously you spoke up about different projects that you've worked on. Is it a proud moment when you see kind of railways being used that you've worked on and things like that as well?
Yes, absolutely. I mean, I went down a civil engineering route when I was training, and the reason I did that was probably because I was inspired by these big structures and bridges and things like that. But it was because you get that real visual impact as well on what you're doing and can see immediately the benefit. And so to me, the thought of software or stuff like that, whilst it's important, that's what inspired me. And therefore, it's really easy for me to see how something I've done or been involved in has had an impact. And, we have a direct impact. I mean, one of the things I talk about in railway engineering, because, we're working on the railway all the time, and yet transporting millions of people all the time. So we can have a huge impact on passengers every day. And we can have a huge positive impact or a huge negative impact. And therefore, when you do something like electrifying the railway from London to Cardiff, we've now got a transformed railway between London and the West Country and South Wales. And you look back and you think, this is pretty amazing, what we're doing and the impact it's having on the country, because it's not just the engineering for engineering's sake, or even for the passenger's sake. The impact that has in terms of economic growth, social mobility, and so on is huge, and that's, it is something that is a really worthy thing that I certainly get enjoyment out of thinking I've been involved in that.
Have you always been interested in trains, Stuart?
I think I've been interested in transport. I think it's that thing that I realized there was something about, and I think it's that inquisitive nature as to how things work. And I said I was in, I latched onto a bridge and understanding how a bridge worked, but I've always been interested. I talked about space. I'm interested in space. I'm interested in boats. I'm interested in railway. It's transport. It's that concept of how things work and how you can make things work for your benefit. Because that's why we're doing it. We're not doing it for the sake of engineering. We're doing it for the sake of it. It helps us do stuff. It helps us do stuff better. And I've just been fascinated by how we can use machines to do things better.
Just linking to that as well, as you've kind of worked through Network Rail, do you have kind of a favourite train at all that you've worked on, or maybe that you've used yourself?
Well, I'm going to say, at the moment, my favourite is anything that GWR do, because I'm in Wales and Western, and therefore I have a huge loyalty to GWR and the Great Western Railway and the excellent trains that we've put on between Paddington and the West Country and South Wales. Class 800s and 802s, for those of you in the know.
Fantastic. So obviously things that you've been working on at the moment and been really kind of invested in is it as well. We do obviously a competition called the Leaders Award, where the participants have to invent something and create something for themselves, and to do this they design something on paper. Is this kind of an important part of engineering, do you feel, Stuart?
Hey, look, I'll tell you what, I've got on my desk here, I've got all sorts of drawings on bits of paper where I scribble stuff down with my thoughts. I'm a massive user of technology, but and I draw on technology as well, but I didn't prepare that. But there's a map of Oxford, And so, you know, actually getting your thoughts down, and even though I use tech to as much advantage as I can, you know, having a notebook and a pen, because you get a thought and you can draw it down, and a picture paints 1,000 words. So absolutely.
So yeah, I think doing that kind of initial design and everything, I think is really, really
I mean,
important.
because you know, this is one of the things about technology. When I was in education at school, I did technical drawing, and in those days it was pre computer aided design, so everything was, you know, ink and pen and drawing, and you spent ages working out how you could interpret a three-dimensional object and turn it into two-dimensional drawings.
Mm-hmm.
One of the advantages we have with computers is, of course, you can draw in 3D straight away. So actually drawing and thinking, because it helps you think how the thing works, you know. And if you're trying to think in your mind, hang on a minute, you know, I've got an idea, and put it down in pen and paper, it probably helps you come up with a better solution, because you're thinking, how does it work, and what could I do, and how could I explain it? Because that's the other thing, you know, we're not just building stuff, we're explaining it, whether it's, you know, from someone building something, explaining it to a supervisor on a site, or, as I said, if you're explaining to a politician the concept of something, being able to explain is probably one of the most important bits of engineering, actually. Being able to explain what you want and what you're doing, and do that is probably every bit as important as the maths and the design.
I think that's brilliant that you explained that as well, because part of the competition, after they invented or designed what they're going to do, is they have to write a letter about what the invention is and why it should be made. So I think that's a really important aspect that you've just explained.
Why is so important, because I come back to, you know, we don't do stuff just for the sake of it. Yeah, you know, okay, some people involved in R&D will be in that space, but most of the engineering we do, we're doing it for a really good reason. You know, and think of some recent examples. Nightingale hospitals. You know, you're doing it for a reason. When we electrify the railway, why do we do it? Decarbonisation, faster train service, everything we're doing is for a reason. You know, so being able to explain why you want something, or why you've done something and what benefit it has, is hugely important.
Fantastic. There's some really good themes there for the participants to think about. Just as kind of we're wrapping up here with the questions, last one I'd like to ask you, and you kind of noted at the end as well, your presentation. Are there any kind of tips that you've learned along the way, or any lasting advice that you could give for the participants listening?
So if I'll come back to the point I made on my last slide, and I think it's that inquisitive nature. Don't be superficial, and by that I mean really understand something. You know, if you don't know, never be frightened to ask why. There is no such thing as a stupid question. There is no such thing. Today, you know, I will get documents today, and I'll read it, and I don't know what it means. And there is nothing wrong with asking until you understand. So I would say, be inquisitive. Don't be frightened of asking the question, because it can be quite tough. I know, you know, put your hand up or say, I really don't know what you're saying, but it's really important, because then you get to the bottom of stuff.
I just want to say a huge thank you to you, Stuart, for taking time out of your day to do this for us. I hope you enjoyed it. I hope you've enjoyed answering the questions there today. Yeah,
no, it's been brilliant. Thank you very much. Really appreciate the opportunity to do that. It's always great fun talking. I wish I could talk to people in person, but doing it from a room in Devon through the internet means I might be able to see some more people than I would in a room.
Fantastic. Thank you. Thank you for those who have been sending in those questions as well. I've also tagged in an online survey for those to complete after the interview today. And I hope you've all been inspired to take on our Leaders Award competition and start designing some of your own inventions, and use our resources at leadersaward.com. So I think we'll end it there. So bye, everyone. Bye, Stuart.
Thank you. Bye.